Okay, class, we're about to start on section 1.4, Basic Rules of Algebra. Our first objective is to understand and use the vocabulary of algebraic expressions. We have seen that an algebraic expression is a combination of numbers and variables. So just as we have seen that x plus 5 is an algebraic expression, x squared plus x minus 3 is an algebraic expression. And finally, let's use a different variable. We could do y to the third power plus 8 is also an algebraic expression. Now, the terms of an algebraic expression are those parts that are separated by addition or subtraction. We have a few examples. We could take the x plus 5, which is an expression, and then we could take the x squared plus x minus 3. And finally, we could take the y to the third power plus 8. Now, over here, we will write down the different terms. Now, for the x plus 5, we could write down the terms are x, comma, positive 5. Because remember, our terms are separated by addition or subtraction. Now we come to the x squared plus x minus 3. As you can see here, this minus 3 is a little bit too far over. So what we would do, we would put a little colon here. So you all know that we have separated this from the terms portion here. Okay, now, the terms for x squared plus x minus 3 are x squared, comma, x, comma, and then this minus 3, it'll be a negative 3. Those are the terms for the x squared plus x minus 3. Now finally, we need the terms for the y cubed plus 8. Our terms will be y to the third power, comma, 8. These are all the terms for the y cubed plus 8. Now, a term that is just a number is called a constant. Now we will look for some examples of a constant. We could go 3, 4, 9, negative 7, negative 11. And these are all forms of a constant. The coefficient of a variable term is the numerical part, which is basically the number that's in front of the variable. For example, we can write 3x, we could write negative 5x, we could write negative 2/3 x. Now the coefficient of 3x is 3. The coefficient of negative 5x is negative 5. And the coefficient of a negative 2/3 x is negative 2/3. Like terms are either constant terms or terms that have the same variable. For example, we could have 2x plus 3x. Both of them have the same variable taken to the same exponent. So we can add them. We have 2x plus 3x, which would give us 5x. Now we could have x to the second power plus 5x to the second power. Now both have the same variable. Both of the variables have the same exponents, so they are like terms. X squared plus 5x squared will give us 6x squared. Now, if terms are not like terms, we say that they are not like terms. For example, if we have 2x plus 3x to the second power, even though they have the same variable, their exponents are not the same, so they're not like terms. Next, if we have 2x plus 3y, we do not have the same variable, so they're not like terms. Okay, now we're about to go to page 11, and we're going to try a couple examples here. Okay, example 1. Use the algebraic expression x plus 2 plus 5x to answer the following questions. How many terms are in the algebraic expression? Now remember, terms are separated by addition or subtraction. So we have two addition signs here. So that means we have 1, 2, 3 terms. What is the coefficient of the first term? The first term here is x. So the coefficient of x is 1. So now we go to C. What is the constant term? The constant term is the number that does not have a variable connected to it. The constant term here is positive 2. Next we come to D. What are the like terms in the algebraic expression? Now we look here. First of all, we look to see if they have the same variable. X and 2 does not have the same variable, so they're not like terms. But x and 5x has the same variable and it has the same exponent, so they are like terms. So the like terms are x and also 5x. Next, we will be working with objective 2, which is using the commutative properties. Okay, we have a commutative property of addition. All this means is that if you're dealing with all addition signs, it doesn't matter the order that you add in, you will end up with the same answer. For example, a plus b is the same thing as saying b plus a. Next, we come to the commutative property of multiplication. If it's all multiplication in the problem, it doesn't matter which order you multiply in. It will give you the same answer. So a times b will give you b times a, or ba. Now, we come down here to example 2. We have a few problems here. We have y plus 4, and it says use the commutative property to write an equivalent algebraic expression. Y plus 4, since that's addition, we know it doesn't matter the order we add in, we will have the same result. So our answer here would be 4 plus y. Now for B, we typically don't see algebraic expressions written like this, x times 9 or x9. Typically we have the number first and the variable second. Okay, so we want to use the commutative property here. So we would take x9 and rewrite that as 9x. Now we look at C. It says write 7 minus 3x so that the variable term is to the left of the constant term. So they basically want us to do the commutative property here as well. But this time it's with a minus sign. So this is what we would do. First, let's change this 7 minus 3x to 7 plus a negative 3x. Now in using the commutative property of addition, we could change this around. We will write this as negative 3x plus 7. So our final answer here is negative 3x plus 7 after we put the constant at the end of the expression. So we're about to move on to page 12. Now on page 12 we deal with the associative properties of addition and also multiplication. Now the associative property goes like this of addition. We have our parenthesis here, but if you notice all of our operations are addition. So we have a plus b in parenthesis plus c. According to the associative property of addition, if we shift those parentheses and it's all addition, we should still wind up with the same answer. So if we shift the parentheses, we will end up with a plus parenthesis b plus c. Now this rule also works for multiplication. Now we have the parenthesis over a times b, around a times b, and we have c on the outside. So if we shift those parentheses, we will end up with the same exact answer. So we have a times b times c. Now we look here at example 3. We have simplify. We have 7 plus the parenthesis of 5 plus x. So what we want to do in order to simplify, we want to get the like terms together. So we could shift this parenthesis because we have addition here. So if we shift the parentheses, we can have 7 plus 5 in a parenthesis and the plus x on the outside of the parenthesis. Now 7 plus 5 is 12. And we bring down our plus x and we are done. Now we look at b. Now b, we have 7 times the parenthesis of 4x. We could shift this parenthesis using the associative property of multiplication, and we could shift the parenthesis to go around 7 times 4, and we will have x on the outside. 7 times 4 is 28, and we will bring down our x. So our final answer is 28x. I want to put these equal signs back in the problem. Now we look at example 4. It says rearrange the terms of 7 minus 5x plus 3 minus 9 so that the numbers can be added. And it asks us to simplify. So what I would suggest first is let's move the variable to the front. So we will have negative 5x first, and then we will shift all of the numbers. This 7 is positive, so it would be plus 7. We'll bring down our plus 3 and minus 9. So we had negative 5x, and then we add the like terms. Positive 7 plus 3 will give us 10. And we bring down our minus 9. Now negative 5x is still not a like term to any of these other two numbers. So we will bring down the negative 5x. We have 10 minus 9, which is positive 1. And our final answer is negative 5x plus 1. Now, we are going to take a look at what's stated down here at the bottom of the page. When the expression contains both constant terms and variable terms, the variable terms are usually written to the left of the constant terms. Now that is a very important statement for you to remember.